Good morning students, myself Dr. Shantani Bhattacharya, Assistant Professor of EC Department, SNM Institute of Science and Technology, Kattankulathu, Chennai. Today I am going to start a new topic of digital logic design is programmable logic array, or in short you can say PLA. Okay, so what is PLA? PLA is a type of device from the class of programmable logic device used to implement combinational circuits. The basic configuration of PLA consists of programmable AND gate followed by a programmable OR gate. In that case, in the previous video I have already uploaded where you can see that there is a programmable, and in the case of PAL, programmable AND array is there, but fixed OR gates is there at the output section. But in that case, both AND array and OR array are programmable. So what will be the design procedure here? Here also we have to design a combinational circuit by the function F1, F2 are the two outputs, and these are the main terms. This is actually the truth table. Here we have taken three basically input A, B, C. 3 inputs means 0, 0, 0 to 1, 1, 1, that means 8 combination, and here two outputs F1 and F2. So wherever basically F1 is 1, so in the position of 3, 5 and 7, F1 is basically 1, so here also it is mentioned like that. Okay, so F2 also same like that, wherever basically it is 4, 5 and 7 position it is 1, so F2 also mentioned like that. Now we have to design the circuit. How to design? So this is the step 2. Step 2, basically based on this function, first of all we have to find out what is the value of F1 and F2 by using a K-map. Okay, so I think all of you know the K-map. If you have any doubt of the K-map, just go through my previous video of the K-map, you can easily understand. Okay, so this is for F1 K-map. As it is a 3 input, there are basically 8 cells are there, and in the position of 3, 5, 7 I have already put the value of 1, and other position you can put 0, or you can set as blank. Okay, so here these two one make a pair and these two one also make a pair. Based on this, F1 will come AC plus BC. Okay, so I am not explaining here the Carnot map again, because I have already clearly explained the Carnot map in the Carnot map video. Please go through again. Okay, so now F2 also it is 3 bits, so 8 cells are there, so 4, 5, 7 position we have to basically place 1, and these two ones make a pair and these two ones make a pair. Based on this, F2 is actually AB bar plus AC. Now you have to design the this basically based on this expression we have to design the basic diagram, logic diagram. So this is actually the logic diagram. So what will happen? This is actually the A line, this is B line, this is C line. Okay, and this is nothing but this is a buffer. In the buffer, this line is for A and there is a knot is there, so whatever is coming through this knot, it is A bar. So similarly here it is clearly explained, this line A, this line is knot, so this is actually the knot section. Okay, so this line A, this line A bar, this line B, this line B bar, this line C, this line C bar. Okay, now all through this line we will basically there are basically you can see there are one common term is there, AC. So one input one output basically definitely it will be AC, and another two outputs are there, so it is BC component and AB bar. So we will design basically 3 AND gates we basically need. Okay, so first of all we will design AC. Okay, So this is actually the line of A, so we make a cross here. Then this is a line of C, so we make a cross here. So when this line is basically AC, so this is actually the AC line. Okay, now similarly BC, this line is B line, so we make a cross here, and this line is C line, so we make a cross line. So this line is basically a BC line. Okay, then A, this line is for A, this is I make a cross here, and then B bar, so this line is basically B bar, so make a cross here. So what will happen, this is the line of AC, this is the line of BC, this is the line of A B bar. Okay, so now we have to find out two output F1 and F2. So two OR gates are there. So in the OR gate, first F1, there is one component is AC, so we will make a cross here. Okay, then another component is BC, so we make a cross here. We will not make a cross here because there is no A B bar component in the F1, so we will don't touch in this line. Okay, so this cross means this cross meaning is actually the connection. Okay, so that means F1 is actually AC plus BC. Okay, then F2 is A B bar plus AC. So this line is AC, so here basically we make a cross, and this line is basically A B bar, so here we make a cross. So output of F2 is A B bar plus AC. We will not make a cross here because there is no BC component. So this is actually the F1 and F2 output, and this is the total logic diagram. And now these are the advantage of PLAs. PLA provide flexible in terms of design and implementation of variety of digital logic operation. It is also minimize the time required to design and develop new digital circuits. It provides less expensive way of implementing highly complex digital logic functions. Okay. Disadvantage of PLAs, for large number of input and output, PLA are highly complex to design and implement. Okay, and PLA is generally optimized for a specific application, and it has a fixed number of AND gates or OR gates, and programming a PLA is a complex process. So the question may come like that, you have to what is basically PLA, you have to basic whatever in my video is there, based on the question I have given all these things. So first of all, basic knowledge of PLA, then one symbolic representation, then one example you have to give. Okay, how to design a PLA by using, or anything they can in question in a question paper or examiner, they can give any example, and you have to design the circuit. Okay, or directly this type of question may come, what is the advantage, what is the disadvantage, and also the applications. So applications, PLA are used in the field of digital signal processing to implement various logical functions such as filtering, convolution, Fourier transform, etc. In control system, PLA are used to implement control logic function of various components like feedback, PID controllers, state machine, etc. PLAs are used to perform different types of arithmetic operation like addition, subtraction, multiplication, and division. PLA also finds their application in the field of data compression and encryption technology, and it is used in different measuring instruments such as digital oscilloscope, protocol analyzer, logic analyzer, etc. Thank you so much. Keep watching. I hope you can understand. If you have any doubt, then give me your doubt in the comment section. I'll try to solve all of your doubt. Thank you so much.